Now that we have covered the reducing of equations in the previous class, today we are going to do reducing of equations to linear when the variable is given as a binomial expression. So for this, we will cover the binomial when it is given in a single variable, binomial when it is given in a double variable, and binomial when it is given in a double variable but with a non-unit coefficient. Please remember here that the unit means 1. That means x plus y, or so the coefficient for x is 1 and the coefficient for y is also 1, whereas 2x plus 1, in that case the coefficient of x is 2, so it is a non-unit coefficient in that case. So we'll go case by case. For a binomial in a single variable, let's look at this question. In this question, x minus 1 is a binomial. So the term is 5 upon x minus 1. So when we take x minus 1 to the numerator, it becomes bracket x minus 1, bracket close, to the power of minus 1. So exponent is minus 1 there. Hence, it is not a linear equation. In such a question, we express or we assume the entire problem. Please remember that this particular thing is a problem. 5 is not a problem for us. So 1 upon x minus 1 is equal to u. And in the second term, 1 upon y minus 2 is equal to v. It is important to note here that the same kind of binomial will be given in both the equations that are given in the pair. So we make an assumption there. This becomes 5u, this becomes v, this becomes 6u, this becomes 3v, minus 3v. So we can solve them using any of the methods. Here we have used the elimination method. The third equation has been multiplied by 3 using elimination. We get u is equal to 1 by 3. And when we put the value of u in either of these equations, we get the value of v. So in this case, we are putting in equation number 3 and we get the value of v also as 1 by 3. But the answer is not 1 by 3 comma 1 by 3. We'll have to put these values now over here. Now, interesting to note here, u is a reciprocal of x minus 1. Hence, x minus 1 becomes the reciprocal of u, that is 3. Y minus 2 is the reciprocal of v. So y minus 2 becomes equal to 3. Solving these, we get x equal to 4, y equal to 5, giving the solution as 4, comma 5. So this question was when the binomial was in a single variable. Now let's look at another example where the binomial is in double variable. Let's look here. First term, both the variables are there and it is a binomial expression, something plus something, right? There are two terms, but it is in a form where again it is not linear. So we make an assumption again for the problem only. 1 upon x plus y equal to u, 1 upon x minus y equal to v. This becomes 10u, this becomes 2v, this becomes 15u, this becomes minus 5v. Again, I'm using elimination here, multiplying this particular expression with 3, with this by 5 and this by 2, and then eliminating, we get u equal to 1 by 5. So we substitute this value in either of the equations. In this case, we've substituted here and we got v as 1. Again, to note here, this is not the final answer. So we are going to again do the reciprocal. So x plus 5 is a reciprocal of u. So x plus 5 becomes 5, x minus y equal to 1. We again apply elimination to this. That means we add these two equations. We get 2x equal to 6, x becomes 3. Put the value So we have x equal to 3. When we put this value over here, we get 3 plus y equal to 5, giving y equal to 2. So the solution becomes 3 comma 2. So this was an example when the variables were given as binomial in every term, x plus y in the first term, x minus y in the second term, that too in the denominator. Hence, this wasn't a linear. We reduced it to the linear using an assumption here. So we have covered these two parts. Coming to the third one, when the binomial is in double variable, which we've already covered here, but with non-unit coefficient. I'm going to elaborate on this particular factor with the help of an example. So let's look here. This is a binomial in the denominator, but the coefficient of x is 3, not 1. And even here. And the same expression is being used here. In addition to that, 1 upon 2 is the coefficient here. The coefficient over here is only 1. The coefficient here is 1. The coefficient here is 1 upon 2. So when we make an assumption for the problem, only the problem is always the expression which does not have exponent value as 1. So 1 upon 3x plus y equal to p, 1 upon 3x minus y equal to q, and we make the substitution here. This becomes p plus q equal to 3 by 4. P upon 2. Please remember, only this part is p. So it becomes p upon 2 minus q upon 2 equal to minus 1 by 8. The denominator is 2, 2 here, taking it common and to the other side, cancelling with this, this becomes minus 1 by 4. So this equation has been reduced to this. Further, solving it, when we add these two equations, equation 1 and equation 2, q and minus q will eliminate. This will become 2p, p plus p, 2p, and this will add and become 2 upon 4, which is half. So p becomes 1 upon 4, right? Now we substitute this value of p equal to 1 upon 4 in any of these two equations. When we do that, we get 1 by 4 minus q equal to this, q becomes this, q becomes equal to half. But this is not the final answer. We'll have to put it back. And remember, 3x plus y is a reciprocal of p. So that means 3x plus y is a reciprocal of p. It becomes equal to 4. 3x minus y is a reciprocal of q. So it becomes equal to 2. So now you'll have to solve equation 3 and 4, which also you can solve using elimination. When we add equation 3 and 4, we get 3x plus 3x equal to 6x, plus y minus y cancel, 4 plus 2 is equal to 6, x becomes 1. Substitute this value of x in 3, it becomes 3 into 1, 3, taking it to the other side, 4 minus 3 is 1, hence y is equal to 1. So your final solution becomes x equal to 1 and y is equal to 1. So what we have covered here is that when we reduce the equations, they could be given in any format. We had covered 5 formats in the previous class and 3 formats in this particular class. The formats here are all in binomial.